Welcome to a new session. In this video, we are going to study dimensions of physical quantities. We already studied all the physical quantities can be derived from the base quantities. So, it can be expressed or represented in terms of some combination of base quantities. For a simple example, velocity is displacement divided by time. We know displacement is length, so it is length divided by time, or we can write it as length into time raised to minus 1. That is, every derived quantity can be expressed as a product of different powers of base quantities. So here velocity is expressed as the product of length and time with the powers of length 1 and time minus 1. These powers or exponents to which the base quantities are related to represent that quantity are called dimensions of a physical quantity. So, dimensions of a physical quantity are the powers or exponents to which the base quantities are related to represent that quantity. So, what is the dimension of velocity? We know velocity is represented by the power of length 1 and time minus 1. So, dimension of velocity is 1 in length and minus 1 in time. What about the power of other base quantities for velocity? We know they are 0. So, power of other base quantities are 0 for velocity. So, what is dimension of a physical quantity? It is the power or exponents to which the base quantities are related to represent that quantity. So, now can you find the dimension of force? We know force is mass into acceleration. So, that is equal to mass into acceleration. Acceleration is velocity by time. That is velocity divided by time. We know velocity is length by time. So, here it is length divided by time divided by time. So, this can be represented as mass into length divided by time square, or it can represent in product form as mass into length into time raised to minus 2. So, dimension of force is 1 in mass, 1 in length and minus 2 in time. Power of all other base quantities are 0. So I think you understood what is dimension of a physical quantity. But it is not easy or convenient to write like this. So to represent each physical quantity, we are using some letters. So now we are going to understand the letters generally used to represent 7 base quantities. First, it is mass. It is represented with capital M. Second is length. It is represented with capital L. Third is time. It is represented with T. Fourth, electric current, represented with I. Next, thermodynamic temperature, represented with capital K. Next, amount of substance, represented with mole. Last, luminous intensity, represented with CD. You can observe these 3 are the SI units of these measurements. Also remember, these letters are written inside a square bracket with correct powers to represent dimensions of physical quantities. So let us look into the example we already considered. For velocity, the dimension of velocity can be written as L t raised to minus 1 inside the square bracket. In the same way, dimension of force can be written as m raised to 1, L raised to 1 and t raised to minus 2 inside the square bracket. One important thing you have to note here is that in these representations we are not considering magnitudes of the measurement. It is the equality of the type of quantity that enters. For example, in this case you can see we are considered the dimension of velocity is L t raised to minus 1. What is the dimension of initial velocity? It will also L t raised to minus 1. The dimension of average velocity, it is also L t raised to minus 1. Dimension of final velocity, it is also L t raised to minus 1. Dimension of change in velocity, it is also L t raised to minus 1. So what you can see here, it is the equality of the type of quantity that enters. So we studied to represent the dimensions of a physical quantity. So this expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called dimensional formula of the given physical quantity. That is, if we represent L t raised to minus 1 like this, It is the dimensional formula of velocity, and this is the dimensional formula of force. So this expression to show how and which of the base quantities represent the dimensions of physical quantity is called the dimensional formula of the given physical quantity. So we are going to write it like an equation, that is, velocity is equal to L t raised to minus 1, and force is equal to m L t raised to minus 2. So we write this with an equation. So this is called dimensional equation. So dimensional equation of the physical quantity is an equation obtained by equating the physical quantity with its dimensional formula. So if we equate the physical quantity with the dimensional formula, then that is dimensional equation. Let us do one more example and conclude the session. For that, we are going to find the dimensional formula of universal constant of gravitation, that is G. We know the equation for gravitational force, that is F is equal to G m1 m2 divided by r square. From this we can write G, the universal constant of gravitation, is equal to F r square divided by m1 m2. Now we can find the dimensional formula of G by writing the dimensional formula of these physical quantities. Dimensional formula of F is m L t raised to minus 2, that we already calculated here, and dimensional formula of r square is L square, because r is the length, divided by dimensional formula of m1 is m, and dimensional formula of m2 is also m. So this is equal to ml t raised to minus 2 into L square into m raised to minus 2. We can solve this and find the dimensional formula of G as m into m raised to minus 2, it is m raised to minus 1, L into L square is L cube, and t raised to minus 2. So the dimensional formula of G is m raised to minus 1, L cube, t raised to minus 2. In this way you can calculate dimensional formula of different physical quantities. So we studied dimensions of physical quantities. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also please like and share this video.